It's 1 o'clock, so I think, okay. I think it's 1 o'clock, so I'll get started. Minasan, konnichiwa. My name is Huyen and thank you very much for coming to my session. So my session is called Loving Lean Layouts, and layouts are kind of one of my most favorite things to talk about with Android. You know, layouts, they're very simple, right? It's just XML. XML's been around for a very long time. Here's the markup. And you know, it's very simple and straightforward, but layouts are the foundation of the beautiful user experiences and user interfaces that we get to make as Android developers. Now, the thing is that because they're so simple and because they're so straightforward, a lot of times we don't talk about layouts in regards to performance. And it really feels like in the last couple of years that performance has, you know, been talked about a lot, right? So the thing is that with layouts, performance you can't ignore performance with layouts. In fact, layouts are a very important part of the performance of your application. So my talk today is to kind of explore how layouts can affect your performance. And basically, if you have problems with performance in your layouts, how to find those problems and fix them. And I'd like to kind of just give some of my personal good practices on how to work with layouts. So just to let you know a little bit about myself, I'm an Android developer. I have been for almost 6 years now, and I'm currently working on the Android team at Trello. And yes, so my talk today will be about 4 parts. The first is why lean layouts, and I'll kind of explain what I mean by lean layouts, and I'll talk about why they matter. Why are you here listening to me talk right now? And I'm going to talk about how do you find problems with your layouts, how do you fix those problems, and again, kind of going over good practices. I personally don't like to say best practice because I feel like, you know, as developers and as engineers, a lot of times what is best for you and your application depends. So I hope to just give you kind of some good guidelines and some good things to follow and think about when you're working with your layouts. So what do I mean when I say lean when it comes to layouts? Well, when I think about lean layouts, I think about 2 things. I think about layouts that are simple and shallow. So simple layout just basically means that if I have a layout, like kind of like this little simple view tree here, if I can reduce that view hierarchy to as few views as possible while still creating and implementing the same UI, I consider the view hierarchy on the right to be simple. And similarly, when I think of a shallow layout, you know, our activities, our layouts are all basically trees. And they have depth, right? Because you can have views inside of other views inside of other views. Now, if I can take a view hierarchy and implement it in kind of like shorter trees with less nesting, then I consider, you know, anything that is kind of using less nesting to be shallow. So that's kind of like what we're aiming for, things that are simple and things that are shallow. Now, why does this even matter? Well, it matters because perf matters, as you might have heard from a lot of the Google developer videos. And you know, with layouts, performance has a lot to do with complexity. And when I say complexity, I mean very literally kind of like the number of views, you know, very literal, how many instances of view classes do you have, and the depth of that tree. And the complexity of a view, of a layout, is directly proportional to the resources that it takes. And those resources could be memory, like again, literally, if you have more views, your application will be using more memory. And likewise, if your application has more views, then you're going to require more CPU time to actually process that layout. So all of that basically, all of those things together, lots of views, very deep hierarchies, will directly affect how many times that your application will have to run measure and layout, how many times those have to be executed in order to translate your XML layouts to something beautiful, beautifully rendering on a screen. And what happens is that if your layouts are not performant, if they have bad performance, you get what is called jank. You know, your UI is stuttery, it stalls, it just doesn't look good. And you know, these days, when we're talking about things like material design, and material design focuses very much on motion design and animation, this kind of performance is just so important. Having things be beautiful and smooth is just vital to not just your user's experience, but also your design. So another thing that is great about lean layouts is maintainability. So in a lot of ways, efficient layouts are good for your user, but they're also good for you as a developer. Now, I mentioned how the complexity of a layout is directly proportional to the resources your device uses. Well, it's also directly proportional to the resources of you're the developer. The more complex your view hierarchy is, the more effort it takes to maintain that and to refactor it. And another thing that is helpful with lean layouts is readability. We, as engineers and developers, we always strive for, hopefully, clean, maintainable code. And part of that is readability. And you can imagine a layout with dozens and dozens of views and dozens of layouts. That's going to be harder to read than a simple layout with 2 views in it. And again, if your layouts are really deeply nested, then all of your views are going to start creeping over to one side of the screen. So again, when you make your layouts efficient, it makes them more readable and makes them more maintainable. And finally, I want to talk about stability. Now, if you imagine a layout, maybe like a relative layout where you get to use all those really cool constraints where you can say, oh, this view is to the left of this one and above that one, and this is that size and that size. When you have layouts that are very complicated, where things rely on each other and are very, very tightly tied together, a lot of times if you change a small part of that, if your layout is too complicated, it's unstable. And what happens is you might change something very small, which you don't think is going to be a problem, but then the rest of your layout blows up. So when you make your layouts more efficient, you make them more stable and more resistant to kind of change. And overall, it makes it a better experience for you as well as your user. So before I kind of go into this, so a lot of the performance issues that we're going to talk about have a lot to do with how view hierarchies are laid out. So just to kind of review, if you have a view hierarchy, start with your XML layout, right? At some point, that XML is going to be inflated, and those views are actually going to be instantiated. So you have your little view instances in memory. Now, before those little view instances can be rendered on the screen, they have to be measured and laid out so that Android knows where to draw them. So there's 2 steps that we most care about today, and the first one is measure, and the second one is layout. And as you might be familiar, the way that happens is that Android will do a depth-first traversal and go from parent to child to that child's child and down and measure each one. And then similarly, after all that's done, then layout occurs. And the same thing happens. You go from parent, lay out the child and that child's child and so on and so forth until you're done. Now, normally, everything happens just fine, right? A lot of times you do layouts and you never even think about how measure and layout are doing. But there are a lot of times where measure and layout don't go as well as you expect. And where do these problems pop up? Well, there's quite a few places. So one of the places where you might find problems with measure and layout is when you have really deep hierarchies. So if you kind of look at this view here, it's really, really deep, right? I've got children with children with children with children. And the thing is that every time you add a level to that tree, you add complexity and you add dependency, because all of these measure calls, all these layout calls from your views will also depend on the measure and layout calls of the children and the children's children. So when you start adding a lot of depth to your layout, you add complexity and dependency, and at that point you're adding, you're using more resources. So another place where you might have performance problems is with change. Now, say you have a view hierarchy, and you have a view, say the one in the pink, right? And it changes size and position. Well, what happens is when a view changes size and position, it might actually affect, if it has sibling views, if there are other views in its parent, those sibling views might also change size and position. So what happens is that the parent of those views have to say, okay, well, you changed, and so I need to relay out or remeasure and relay out all of my children. But the thing is that when the children of a parent change, sometimes that parent could change size and position. So that means that parent, if it has a parent, then that parent has to say, oh my gosh, okay, everything's changing, now I'm going to have to relay out. and it goes up and up and up all the way to the root of the tree. So what happens is that any kind of change at some point in your hierarchy, whenever something happens, then all these kind of calls, everything has to be invalidated all the way up to the root. So, and that will just basically continue to call measure and layout again. And like I said, that's when you start running into performance problems. Now, this is kind of interesting because, I mentioned material design and animation, but what is animation but change? So, sometimes problems are things that you can avoid, and sometimes problems are things that you're trying to do, right? We want to do animations and make our applications look beautiful. So in a lot of ways, this is a problem that we can't avoid and something that we have to deal with, and something to be very aware of. So another place that things come up are with layouts that come from the platform. So think about relative layout. Relative layout is great and useful, right? You can do so many constraints. But the problem is that something like relative layout, it actually requires on its own, requires 2 measure and layout passes. And that's because you have so much power and ability to lay things out with such constraints, it actually has to do 2 passes to be able to both lay things out and be able to satisfy those constraints. So anytime you use relative layout, you're automatically kind of penalizing yourself for another measure and layout pass. Now you might say to yourself, well, that's not too bad, one more, right? Well, the thing is that when you have problems with layouts and performance, the effect is not additive. It's not like you're just adding one extra, you're doubling. So if you think about, say, a relative layout had another relative layout in it, the parent relative layout does measure and layout twice, but the child ends up going through it 4 times. So as you can see, you have to be very careful and kind of understand what the platform layouts are doing, and kind of try to minimize any of this this multiplication of problems, because everything kind of just piles on and piles on and piles on. So finally, lists. So say you have a layout and it's not too bad, it's kind of complex, but the performance is good. Say you put that layout and make it a list item. So the thing with lists, and lists are very common, right? Most apps you see have some kind of list. Well, a list basically will take a view hierarchy and make a lot of copies of it. So if you have a view hierarchy that's not too bad, but you start copying it over and over again, you start taking those little problems and then multiplying them again. So again, lists might be some place where you have a lot of problems, and kind of just pretty much the thing is any of these problems you can have. And the tricky part is that you never kind of run across any of these problems or any of these problem areas on their own. Usually they come together, right? You see 2 or 3 or all of them all at once. And again, even if a problem seems small, a little bit of inefficiency in one list item, a little bit deep here, when they multiply together, at the end, you might end up with something kind of exploding in terms of bad performance. So it's always good to try to optimize where you can and make things better where you can, because of all these things, kind of working together against you. All right, so step 1 in my loving lean layouts is to be able to find problems. So there's quite a few tools that allow you to look at your layouts and try to figure out where some of these problems might be. And the one that I want to talk about today is Hierarchy Viewer. So Hierarchy Viewer is this SDK tool where you can take an activity and actually visualize its view hierarchy as a tree. It used to be a standalone tool, but now it's in Device Monitor. And it actually will give you an indication of the performance of measure, layout, and draw. And it does it in 2 ways. It gives you kind of just the raw amount of time, the raw milliseconds that each of those passes takes. But it also kind of gives you a notion of how good it's doing. So it'll kind of show you, oh, this is slow, this is okay, and this is doing efficiently. And you can actually see that in the Hierarchy Viewer. And just kind of a tip, Hierarchy Viewer is kind of best and most easiest used on a physical device running 4.1 and up. There's some details on that, but basically if you run a Hierarchy Viewer on a device that's 4.0 and below, you kind of either have to have an unlocked phone, or you need to run ViewServer, which is like a local server. So usually it's easiest just to find a physical device running 4.1 and up. So I'm actually going to show you an example of using Hierarchy Viewer really quickly. So we'll bring visor up. Okay. I apologize, I would have this all set up, but my computer doesn't seem to like visor and Keynote at the same time. So we're going to go ahead and pull that up. Okay, so I actually created several examples for you in this application. So I have a layout here, which looks really great, but I actually kind of implement it in a bad way. I did a lot of things in this layout that I'm going to ask you not to do when you develop your layouts, and there's a lot of images. And what I'm going to do is I'm going to open up, I'm going to go to the device monitor and let that open up. And you can do all of this directly from Android Studio. So what happens is, I'm going to go to my hierarchy view. And so hierarchy view will actually give you a list of activities. So as you can see here, I have my main activity, and then I have that specific hierarchy viewer activity example. So I can click on one, and let's see. It takes a little bit to refresh it. Sorry. Okay, here we go. So as you can see on the right here, I have my entire layout as a tree. And this is very helpful where you can kind of have a very big overview and you can kind of simply see where problems might be. So if you see a lot of these rectangles grouped tightly together, you might say to yourself, oh, okay, there's a lot of views there. Maybe I can reduce that down. Or if you see that your tree is very, very, very long, we're like, well, okay, my view hierarchy is kind of deep. Maybe what can I do about that? So there's a couple other really great things about the hierarchy viewer. So if I say click on a node, so here's a relative layout, and I'm going to click on measure that. I'm going to pull that up a little bit. So as I mentioned before, it shows you performance in a couple of different ways. So first, it might be a little hard to read, but here you can see that it actually shows you the time it took to measure, layout, and draw this view group and all of its children. And it doesn't just give you kind of the numbers, but it also kind of gives you this, it gives you yellow, red, and green dots. And basically that shows you, bad, okay, and good in terms of performance. And so if you just kind of click along, you can kind of see kind of basically how well, let me zoom out a little bit, how well my hierarchy or my layout is doing. And in some places it's doing kind of terrible. A lot of red dots here and there. Another really cool thing about the hierarchy viewer is that when you click on each node, you will actually get, it might be a little hard to see, but you actually get a preview of your activity, but just the part that is drawn by that particular node. So it's really cool. It's easy to kind of see what particular part of your layout is performing poorly. So that's hierarchy viewer. All right. Now there's a couple other tools that you can use that I'm not going to talk about, but there's also systrace. So you might have used systrace in order to look at different system and application threads and kind of examine how they're executing. Systrace actually is able to kind of let you know when frames are rendering, whether they're doing slowly or not, and whether those frames exceed 16.6 milliseconds. That's basically the amount of time that a frame has to render to match 60 frames per second. You can also use dumpsys. So basically dumpsys will collect a lot of what the documentation calls interesting information about system services and basically just kind of make you a report on it. You can pass dumpsys this argument called GFX info, graphics info, and it will give you kind of like, it'll kind of do a summary of a lot of different information related to animating of frames. There's a new argument called frame stats, which was available on Marshmallow, and that gives you exact kind of basically timings of the measure and the layout and the draw. So if you really, really want to look at very exact timings, you can use frame stats on Marshmallow. Okay, so now that we know how we can find problems, how do we fix problems? Well, the easiest place to start is with our friend Lint. So I really like Lint a lot. Lint complains a lot to me about my code, but usually it's complaints about things that are good for me to fix. Anything that Lint complains to you about with layouts are things that are usually straightforward and that are usually things that you should pretty obviously not do. And there are things like don't nest weights, remove like view groups that don't have any children, and don't nest too much. So I actually have an example of that as well. So let's go back to Visor. And so I have a really kind of weird view here. A lot of things going on. I've got this kind of pink and black monster down here. So if I actually go to the code for that view, Now, as you can see really quickly, you see on the right here, Lynn's already kind of complaining at me. And if I go to like kind of like the first thing here, you can see that if I just highlight it, it says the relative layout or its parent is useless. So if you kind of take a look at what's going on right there, you can see I kind of did something kind of silly. And I have a relative layout inside of another relative layout, and there's only like one child. And as you can see, that's pretty obvious. Like I made a pretty bad like layout choice here, and it's pretty simple, right? I just have to remove one of these views and maybe adjust some padding and layout, and I've already become more efficient. And I've basically both reduced the number of views and also reduced the depth of my hierarchy pretty simply. Now, if I look at some other things, you know, some more useless views. So another thing that, excuse me, that you might tend to do. So, you know, as we're trying to build our beautiful layouts, sometimes you might find yourself wanting to, like, you know, a divider or maybe add some space. So if I go back to my application here, so sometimes, you know, when you're doing a layout, you want to position things correct, like in a very particular way. So you might add a view here to just hold that space. You might have dividers. And I think, like, I know I did this when I first started doing Android, is that I would just plop in a linear layout, right? Because I like linear layouts. I just might plop that in and try to make it a space, you know, to do that space, to do that divider. But the thing is that linear layout, because it's doing so much, there's actually like a lot of overhead and things that it does other than just, you know, exist. So it's usually bad to do that, and Lint will warn you when you have a view group that has no children, no styling, no anything. So the best thing to do there is just to use either a plain view, like you can just go ahead, and it took me a while to figure that out, that you could just put a plain like view tag and just stick it in there if you need a divider and set the background, or to make a space. And actually, in talking about space, there's actually a space widget. So this is kind of interesting. If you really want to have like non-breaking space, I guess, kind of like back in HTML, you can actually use a space widget. Now, the space widget actually has a lot of stuff taken out of it because the view has a lot of logic for doing backgrounds and other things. So if you really want to be efficient and just stick space in there, you can use the space widget. And I think it's in the AppCompat library. So another thing that Lint really doesn't like and that you should not like is nested weights. So if you think about weights in linear layouts, right, you're basically giving the linear layout some constraints on how you want certain views to be positioned. And it has to do a lot of calculating, you know, kind of like, oh, this one wants to be this size and that one wants to be this size, and the leftover goes. So there's a lot of things going on. So the problem is that when you nest them together, basically you're making a lot of work for that inner view. So that inner view will calculate things, but then the parent was like, oh, no, you need to be this size. And the child goes, okay, well, I guess I have to lay out again. So basically, this is why Lynn says that nested weights are bad, because you basically are making all of these children do a lot more measure and layout work. So as you can see here, I have two linear layouts that, so one has weights, the child has weights, and there's weights on the inside. And Lynn's like, no, that's bad for performance. So as you can see, this is kind of a pretty obvious thing that you probably shouldn't do. And there's probably a lot of, if you're seeing this, there's probably a better way of doing this. So it's always good to listen to Lynn in these cases. And that's just ugly anyway. You should never do that kind of thing. So, okay. So basically, if Lint is happy, you probably will be happy or happier. So in terms of fixing problems, like another thing that is good to do is to simplify and reduce. We're engineers and programmers. We kind of like can find probably like hundreds of ways to do one thing. And with layouts, it's always good to try to find the simplest way to do things. And a lot of times when you're first starting out with Android and layouts, you tend to just try to focus on making your UI look exactly like how the design works. And a lot of times you might be using more views than you need to. So let me just bring up my example again. And so, okay, so this is kind of something we see in Android a lot, right? So we have an icon next to some text. You see it everywhere. And if I look at the code for that, okay, so this is probably something that if I just start out Android and I see like an icon next to some text, I probably would think to myself, oh, well, I should just make a text view, make an image view, put it in a horizontal linear layout, and I'm done. And that's what I did here. And as you can see, it works. But you can see, oh, here's our friend Lint again saying, oh, by the way, you don't have to do this. You can use what are called compound drawables. Now, compound drawables are attributes on the text view, and basically it gives you 4 places, top, bottom, left, and right, where you can actually assign a drawable, and text view will do the work of putting that drawable in the right place for you. And you can even add some padding and adjust it a little bit. And so here, this image and text on the top is my linear layout with an image view and text view, whereas this on the bottom is pretty much the same thing, but with a single text view. Now, if you look at my code, it took me 3 views, the linear layout, the image view, and the text view, to do the same thing that I could do down here with a single text view. So I basically moved 3 views to 1, and I reduced the depth of my hierarchy by 1 as well, just by using an attribute that's already on text view. So, and this is kind of like another extreme example here where I have an image, I have like some text in here, and I have 4 images on the side, and the same thing down here. And as you can see here, I have a relative layout, and I've got 1, 2, 3, 4, 5 views inside, whereas I could do the exact same thing with a single text view just by putting all of the drawables in the compound drawables. So you can see it's just really handy to have, just these attributes that allow you to just really make your layouts very lean. And like I said, you can achieve the exact same like visual design effects. So let's see. So I kind of, this is kind of something I come across sometimes especially when I was like first doing Android, is that, and I don't know, I used to do this on iOS a lot, in that when sometimes you have like a background color, like a background image, and your instinct is to say, okay, I want a black background here. How about I wrap everything in a frame layout and make that frame layout black? But you don't have to do that. As you can see here, I have a frame layout here with a background, and I have a linear layout with 3 images. But I didn't have to do that just to achieve this effect. On this bottom one here, if I just make sure that I remember that I can always set the background or set padding or set margins directly on my content, then I can, again, reduce my layouts by make it 1 less deep and use 1 less view. So sometimes it's kind of hard. Things like that, like when you try so hard to make your UI fit design, you tend to try to do things that seem like they work, but there's always like things you can try and always things you can do to make things simpler. So yeah. Okay. So say that you made Lynn happy. Say that you simplified things as you can, and you still cannot get the performance out of your layout. Well, you have another option, and that is to go custom and to create your own custom view groups. Now, I'm going to go ahead and cut exactly right to an example here, and oh, sorry, I actually skipped some slides. Sorry. Ignore what I just said. Sorry, skip some slides. Let me do that. So using attributes is a good thing. But there are other things that you can do to actually simplify and reduce your views. So there are things that are not attributes, things like the spannable class that you can use to simplify your layouts. So I'm going to go back to my example. And so here I have some text, right? So I'm trying to render a conversation, right? So I have maybe one person talking, and then I have another person responding, and another person talking again. And I want to make like each side like a different style, right? To show that I have like maybe 2 people talking. If you're first starting Android, you might think, well, I can create person A text in one style, person B's text in another style, and then I'll just create 3 different text views and just assign the style to that text view. Well, that's okay, but you now have like 4 views, right? You have the container and you have your 3 text views. But you can actually do all of that with a single text view by using spannables. Now, if you haven't used spannables before, spannables are a way of basically taking a character sequence and assigning styling to just a subsection of that character sequence. And let me say here, views activity. So I can't go into too much detail, but and there's a lot of great presentations out there about spannable, but basically I do a little bit more work in the Java side, and what I do is I kind of build up the spannable, and I basically am indicating, oh, well, from this position to that position, I want this style in the text, and in the text at this position and that position, I want a different style. And basically after all this setup, all I have to do at the end is call text view set text with this styled string, and I will get out the exact same look with like the different alignments and different styles all in the same text view. And as you can see, rather than having, like all of these linear layouts and all these text views, I just need a single text view, and I give it that, that character sequence with a whole bunch of spannables in it. And I've again, reduced the number of views, reduced the depth of my hierarchy, just using like a different tool and a different technique. And there's other things like this, like if you want a divider linear layout, actually has a divider attribute. And again, just to reiterate, if you're trying to just do things like dividers and placeholders, don't be afraid of just putting a regular view in there and styling it. And sometimes it's all about just picking the right view or layout. So if you can see down here, I have 3 views. So it's a little hard to read, but basically I have 3 text views. And say that I wanted to have 2 of them aligned vertically, and then the 2 together is a group aligned horizontally with another text view. Well, if I was first, I might say to myself, well, I could do one linear layout for the 2 that are on top of each other, right? And then I could put that in another linear layout and have those aligned horizontally. Well, that works, but that's like a lot more views. But instead of doing 2 linear layouts, what if I just picked a relative layout and just use, it's kind of like constraints to do the same thing? Well, that basically saved me. That will save me a lot of work. So at the top here, you can see how it's a little hard to see. So here at the top, I kind of did it that kind of simple way that I mentioned before, where I have a linear layout, another linear layout, and all my text views inside. Whereas if I just used a relative layout here, you can see I can just put all of the text views inside that relative layout. And that's it. I've saved myself, again, another view, another layer. So a lot of times just making things lean is just picking the right layout. Okay, so now we can talk about custom views. So again, if sometimes you might find that you make the right choices, you make things as simple as possible, and you still don't get good performance. So sometimes the best option is to do custom view groups, and it has a lot of really good advantages to that. So like, if you do a custom view group, you get total control over what happens in the measure and layout logic. There's none of this silliness with like relative layout doing 2 passes, whether you want it to or not. You get to control that. Now, the disadvantage is that doing custom view groups is pretty difficult. It takes a lot more code on your part, and it just could, and it's you might be prone to errors just because you don't have that nice platform layout that's already been tested. So if you've never done custom view groups before, I do encourage you to try. If you're just starting out, think of try to pick out a simple straightforward layout to work with, and try to do a custom view group with it. And there's lots of very great presentations on how to do it. I really can't cover that since I don't have much time, but I can kind of show you a quick example of what that might look like. So actually, looking at this is my recycle review that's kind of like the launcher from all my examples. So this kind of list item with the icon and the title and the subtitle, we see that a lot, right, in material design these days. It's very common. So the way I did this at first is just, well, kind of like my example of just before, I could just use a relative layout for that, right? So list item example. So here I have a relative layout, and I have my image view and my text view and another text view. And that's great, right? It's like I said before, that's pretty good. But I personally don't like relative layout. I don't like the double measure layout pass thing. So what if I try to do this as a custom view group? Well, I did. And if I open that up, so there's going to be a lot of code in here. So the thing is that, as you can see, it's a little bit extra work, right? I have to create a custom view group. I have to actually do my on measure and my on layout by hand. And it seems like a lot of extra work, and it is. But if you have like a layout that is not changing, that's very straightforward, the layout logic is kind of simple, it could be kind of like not too bad to get this done. And the advantage is that now I know exactly how many times, or I know exactly what's going on. This is not going to happen twice. Everything is laid out exactly once in exactly the position that I want it to be. And kind of like the nice thing about custom view groups too is that they don't have to be, that they can look a lot like the platform layouts as well. So here's me actually using my custom list item, and the layout looks pretty much the same as the relative layout. You know, I'm able to kind of just put my children directly in the view group, and you know, even though it looks the same, it doesn't have that extra penalty of the extra measure and layout. So, you know, I encourage you to, you know, if you think that custom view groups are for you and can fix your problems, to go and try it. And if you're really brave or you're really adventurous and want to challenge yourself, you can also do totally custom views where you draw everything on the view canvas yourself. Now, it's also really important for me to say that, you know, I really like view groups. I like doing custom view groups. I might like them too much because a lot of times you have to balance the performance benefit that you get out of doing something like that with the development effort. So, I mean, if you're trying to just do a view, like you know, we all have to have deadlines to meet. We all have to get actually features, you know, done. And sometimes just kind of trying to make a layout efficient by using custom view group might not be the best solution. It might just be relative layout or something like that. So I encourage you to try custom view groups and custom views, but again, always kind of consider like the balance of the actual performance benefits you get out of it with the amount of effort that you will need to put into it, because it is, you know, it is very significant. So finally, good practices. So I kind of have like some good guidelines that I try to keep in mind when I'm doing layouts, or I'm getting to build a layout for the first time. And kind of like my number one rule for myself is just to kind of anticipate and practice good habits. So it's a lot harder to like refactor a layout that's kind of gotten messy and gotten like unperformant than it is just kind of like think about and plan things ahead of time, right? And to kind of like make things lean to begin with. And that kind of goes along with, you know, this idea that that it's just kind of easier to have good habits and just do things right from the start. And you know, even if you cannot do that, you should know how to identify possible problem areas. So again, that's kind of also kind of like a little bit of experience, but also a little bit of thinking beforehand, like, oh, I have a lot of lists. My list items might have a lot of data in them. I should kind of be careful about how I lay them out, or I could consider different things. So things like that. Another good kind of rule is to kind of always use simplest solutions where possible. And it is really important as we're building our, you know, beautiful apps to kind of, you know, create our designs and make things look beautiful and pixel perfect. But a lot of times you can do that with simpler solutions. So always try to kind of think about where you can simplify things and where you can reduce things. And again, that means fewer and flatter views and view groups. There's actually was a great talk at the Android Dev Summit given by Chet Haas and Romain Guy, and they had a part where they talked about kind of view hierarchies and UI styling and ways to kind of reduce this. And I thought there was there's one part where Chet said, basically don't do too much stuff. And I think that's a really good thing to keep in mind. And that's kind of what we're talking about, right? Don't do too much. Don't, you know, make your layout have to go through too many measure and layout passes. Don't put too many views where you don't need them. And another good thing that they mentioned is never use relative layout in the root. And they kind of mentioned the fact that in Android Studio, when you make a new activity, it just puts relative layout right at the root of that layout file. Don't do that. Please change that. So, and so finally, don't let problems accumulate. And you know, it's kind of tough. You know, we all work in teams. We all have deadlines. So sometimes you have to just get features done, right? And it's kind of hard sometimes when you're on a big team or have a lot of people to work with for you to always very closely and precisely do everything as efficiently as possible. Sometimes you just have to kind of get things working, and that's okay. That's really okay. But at some point, you know, you have to kind of be aware of problem areas, and if you do have to kind of clean things up or you do have to kind of refactor, don't be afraid of it, and just be aware of when you might have gotten to that point where things are becoming a problem. And again, you know, like, balance the performance benefit with the effort required. You know, I try to keep things simple if you're going to make improvements. Always start with the simple first. Start with lint. Just reduce views. And when you actually have serious problems, then you can start pulling out the complicated and challenging solutions like view group and view. So it's always about balance. Well, thank you very, very much. That was my talk on layouts. I would love to take questions. In general, if you want to ask me questions or about this or anything else, please find me on Twitter or Google+. I also, my good friend Chuki-chan and I also have a YouTube channel where we talk to Android developers, so please check that out. The slides are actually up on Speaker Deck right now, and all of the code that I have with both the bad and the good examples of layouts are also up on GitHub already. So if you have any questions, I'd love to take them.